Circle Optics, our mission is to deliver situational intelligence for a safer, smarter, more immersive world. And through our patent stitch-free parallax panoramic imaging systems, we help defense, aerospace, and robotics professionals improve how they perceive and respond to their environment. At this time, Circle Optics has 18 employees, some interns, and a couple of consultants. We have 23 patents and pending, and are very excited that we're actually beginning to do work outside and beginning our commercialization process. And because of that, it was really exciting for us to begin to think about how do we tell our story, not just with Zach and Ian, our founders and COO, but also the people behind the scenes that are actually putting the optics, mechanics, and software together. The first episode of Stitchless with the mechanical team, you got to meet all three people of our mechanical team. This particular segment, I'm speaking particularly with Bob Stanchis and Carlos Terrera, talking a little bit more about Pegasus and Hydra, our camera systems in particular, and the mechanical breakthroughs. And I'm going to go ahead and start with one question. And I'm addressing you both. And so when you feel free to answer, go ahead and answer. But for the first time that people hear your voice, state your name, just so that people get used to your name, and then we can be a little bit more free. So what does mechanical excellence mean to you in the context of our camera systems, both Pegasus and Hydra?
So this is Carlos, and I believe for us, it comes down to precision and accuracy. Essentially, in the Pegasus system, we have multiple channels, and they have to be oriented in a specific direction, and they have to be precisely located relative to each other. And we've employed some methodologies that we've learned in our long careers. One specific one is exact constraints. So this is where we're trying to make the system robust to thermal vibration effects, but also make it repeatable. So when you remove a channel and put it back in, it returns to the same exact position. And this helps maintain the system integrity, and also lifts the burden off of the software calibration. So this is one of the things where you could call it a breakthrough, unique to the way we build cameras.
I'm Bob Stanchis, and so I think one of the things that we're doing a little bit more of is trying to make some earlier prototypes on not doing the entire product in one shot, and so we can learn from some prototyping or breadboarding, you might call it, where you take parts of the system and start putting them together, and learn from that before you put the whole thing together. And 3D printing has helped a lot with that. We're using 3D printing a lot more for our fixturing because it's just fine for fixturing. It's even fine for some of our finished parts. But so we're working a little bit harder up front before we get too far engaged in the full product.
That's great. We will have some photographs of the Pegasus system here. Is there anything in particular you want people to notice when they look at Pegasus that makes it, again, what makes Circle Optics so special in the way that it actually puts together optical systems?
Yeah, for me, I would say the lenses look unique. Our lenses have a unique look to them. You can notice that the lenses are not round; they're truncated. This helps us pack the system tighter and get a smaller size and weight, and still maintain the angle between the channels. I think that's a particular feature to notice.
Yeah, I think one thing that's really neat about Pegasus is that it looks elegant. And I've always said that when you have worked long enough on an engineering problem, that the solution is elegant enough for your boss to look at it and say, "Why did it take you so long?" Right? So it has an elegant look to it, and at first glance, it looks pretty simple. But if you really look, down deep into the mechanics of it, it's not all that simple.
And I love that you're designing it so that the lenses can be replaced and that ultimately other people will be using the systems that aren't engineers. And so I love that level of design integrity, design simplicity. And even though it is, and I can't imagine Zach ever saying what took you so long.
No, he hasn't.
I was going to say, just because the whole system, it just takes so much patience. Let's talk a little bit about Hydra. We're on series 3 on Hydra. How did the internal structure evolve with Hydra 3?
Yeah, on Hydra 3, initially on Hydra 1, we had a very nice design, but it was held together with very tight tolerances and potentially over-constrained, and that posed some issues. And for Hydra 3, we wanted to go back and look at that design. And what we ended up doing was looking at the internal structure that holds all the camera channels together and simplifying them, reducing the number of parts, in which made it easier to tolerance and locate. But essentially, it consists of a dodecahedron. So imagine a dodecahedron. Each face is a mounting location for each channel. And we split it in 2 halves. The top half holds 6 channels and the bottom 5. And the most bottom channel, the most bottom face of the dodecahedron mounts the post that holds the whole structure together. And so it's a very elegant design. But it came about from learning from our past mistakes and building upon our previous designs.
What I love about the evolution that's happening now is that we learned that we can create one system that can also be used on a pole for surveillance. And the idea that there's, if I think of agriculture, I think of surveillance in general, but agriculture applications. I like the idea of us beginning to have different use cases with the same system, and so I'm real thrilled about that particular evolution. How about for you in terms of the inner structure of Hydra 3 and how it evolved?
Yeah, Carlos is exactly right. We did learn from the first ones. But one thing that we were doing on the first ones was we were trying to make the most absolutely perfect high tolerance assembly that we could because we didn't have a whole lot of tolerance there to work with. And in Hydra 3, it was a little bit scoped a little bit differently so that it gave us the leeway to relax on some areas. And we took advantage of that to get more room for a simpler assembly and came up with a pretty neat, elegant solution that really has some legs that it could really, we can change out the camera channels for a different system, all on building on basically the same type structure.
I understand that we're beginning to work on infrared capability. And so my question for both of you is, how do you balance weight, thermostability, and ruggedization for field use? And do you want us to stop adding variables?
Yeah, so it comes down to thinking of all these things early on. We have to take into account the environment where the system is going to be deployed. And it could vary. It could be a desert in Texas, or it could be in space. And these bring their own challenges in terms of the environment, specifically vibration, shock, and thermal impact. And so those are things that have to be learned early on and incorporated into the design. And, that they come with challenges, but each system is unique, and we approach it in the same way with the same thoroughness.
And it isn't a hyperbole to say from a desert in Texas to space, because we're part of the TAC-RS program that is actually looking at between MEO and LEO, detect and avoid. And one of the things we care about is making sure that the Chinese satellite system, or that the Chinese don't in any way disrupt our satellite system. So that is a query that Circle Optics has been looking into, just for our listeners. Same question for you. just in terms of balance, weight, thermal stability, and ruggedization in the field.
Right. Well, one thing that we've been doing is we've actually been putting. We have a test setup that we take our Pegasus, and we actually put that into some of those vibration, shock, all those kind of thermal issues into testing for that, and we're learning from that, and so that's one part of it is getting into that test and seeing how you're performed, and then making changes to fix things that might have broken. And also you might find out that you've got a little more leeway to relax some of your design too.
That's it. And Bob, in particular, how do your mechanical choices influence or reduce post-processing in the software?
So everyone has their needs in the project, whether it's mechanical, optical, electrical, and software, right? But the software folks are usually about the last ones that deal with what we put out there, and so we need to give them some leeway on let's say what the sensor is actually picking up on, and they need to figure out how to calibrate the camera, and we need to give them ways to do that physically. And the more ways we give them and the easier the setup, the quicker they can work it out and get a good result.
That's great. I've been seeing some flight testing. I've been seeing our products beginning to be tested in the market and that sort of thing. I'm curious to know what each of you are working on today. I'm going to start with you, Bob, and then go to Carlos.
Yeah, so right now I'm working on a layout for a new lens barrel, for a new optical layout that we're working on for LWIR, and we're it's a first time for me to work on that, but we have a lot of help, and I'm able to work through these different issues that you come up with. Some of them are really very different in LWIR, and so there's a few extra things for cooling that we need to do, and that's been a fun challenge. And we're making it fit, and we're coming up with a good design. That's
great. Carlos, what are you working on?
Yeah, so essentially wrapping up our Pegasus program, and also building the Pegasus Pro program system that will be delivered to NASA shortly, and thinking of also planning future projects, specifically on the LWIR project with our Phase 2E with NASA that was recently announced. So working on making a solid plan to deliver a system within a year. A breadboard to test out and show what we can do.
And with that press release that you were involved in, Carlos, we were able to announce that in addition to NASA, L3Harris has been working with us. So we actually have an application that won't just be delivered to NASA. It'll hopefully be our very first commercial product. Anything you want to say about that particular project? Because I think you're the private investigator for that.
Yeah, well, first of all, I'm very excited for this project to have a partner like we're working again with NASA, and then continuing to work with L3Harris is quite exciting. And it's new ground for us. This is a different system that we usually build. We usually build systems that are in the visual domain, not in the infrared domain. So we're, for us, it's going to be a learning curve, but we're up to the challenge, and like I mentioned, it's very exciting work ahead of us.
Is there any way that any of us on the team can be more supportive? I know it's sometimes how to anticipate how to help when you know what to do, but like your skill is so specialized. Is there any other ways that our team can be helpful in supporting either of you or the team?
Well, I'll just say that you're like our number one cheerleader in the company, and you always come in with a smile on your face, and you know you're good to work with. You're like just how can we show this to the world? And some of our stuff we're like, well, we don't want to show that to the world yet. It's not ready, or we just shouldn't show them because it's Circle secrets.
I love that.
So, but I appreciate when I'm surrounded with people that are upbeat.
That's great. Thank you for that.
Yeah, I want to echo that. I think it's very important for you what you're doing and how you're essentially showcasing the work that we've been doing. So it's nice to see our work up in the posts and social media, and have others see what we're up to. So it's a sense of pride for us to see our work out there.
So what you can expect going forward from me is creating ways that are accessible for the team to talk about our technology, so that we're all kind of saying similar things and are clear on what we can say publicly. I thought that was a great reference that you did, Bob. And when you see Hydra out and about, it actually has a QR code. And I remember when we were getting ready to do our testing at the Rochester Museum and Science Center, and Bob says, "Shouldn't it have our logo on it?" And so it's really neat to see Mechanical also taking on the responsibility of the co-branding and all of that. And I will continue to make it easier and easier for everyone on our team to talk publicly about what we're doing. And so thank you for your time. You have been listening to segment 2 on Stitchless, talking to our mechanical team about the mechanical breakthroughs that make Circle Optics so very special. I hope you join us for our 3rd segment of Stitchless, where we'll be featuring one of our newest hires. Thank you for joining us.